Okay, good morning. Today we're going to continue on to the lesson that we did from yesterday. You're going to see a lot of repeat of stuff that we reviewed yesterday from previous years about relationships, trend lines, and correlations. Today our big objective is that we can write an equation once we write that trend line. Because that's going to be the high school part, is that we're going to draw that trend line and then we're going to use it to collect more information that's further out. Okay, so go ahead and do this warm-up real quick. Study the labels on the graph and answer those 3 questions. Pause your video and come on back when you're all done. Alright, let's see how you did. Yep, you see some writing on mine. You'll even see where I drew a trend line here to try to make a prediction out here. The pattern you might see is something along the line that the coordinates or the points are going up as I read my graph from left to right. When they ask you about the relationship, you need to kind of put the labels in words, kind of like we were wording yesterday on the homework and the paper we did yesterday. As the screen size increases, so I'm saying what my x-axis is doing, and my label there's my label. As this guy increases, and that's the way it's always going to start out, your x-axis is always going to be increasing. Then you say what the y-axis is doing. The cost of the TV increases. So there's the cost. There it is in my label, and I said what it does. Okay. So now we're going to make a prediction. So you have to make a trend line pretty much right there. And we did that on our work a little bit yesterday. I had you drawing some trend lines. So don't force this as well. My trend line is a little bit below 450 here. So I said about 440, because that'd be 450. Some kids want to force it like it's always whole numbers. It's not always whole numbers, so you got to be more precise in your answers here, in your estimate. Okay, mine's a little bit below that. Now when it came to the 60-inch TV, they did this on purpose. My 60-inch is like way out here. So that dot's going to be like way up here. And so I have no idea. It's really hard for me to make an estimate, but I would say that's about 600. And so I said 650 kind of, but I'm not real confident about that guy out there. So that's what makes it tough. But if I have an equation out here, sorry about that. If I have an equation, then I know fairly accurately what that trend line would continue to be out here. So I drew a trend line to explain how I got those costs. It says I drew a trend line to help find the points for an estimate. That's what a trend line is. The best educated estimate by drawing the line down the middle of the data. Alright, so today our big deal is to not only draw a trend line, which is the line drawn down the middle of the data, but we're going to write an equation for that trend line. Okay, positive correlation, but now they have this word association, which means the exact same thing. So positive correlations, our dots are going up. Negative association, we learned and reviewed yesterday. Our data points as we read from left to right are going down, and no association would be they're like all over the place. There is no pattern. Okay, pretty easy review from yesterday. And so they're going to take a good portion of our notes today talking about positive association, negative association, and no association. But now we're studying labels and things like that in real world problems. Hours after sunrise. Well, that means the sun's coming up, so the temperature should be going up. So it looks like they measured the temperature multiple times through the morning. Now let's talk about this guy. This thing's called a broken graph. And so the other day when we were making a graph and I said your graph should take up most of this space on the axis here. Well, we really never go below 65, and so there's a whole lot of room down there below 65 to 0 that's not being used. So what they do is they say, well, let's cut that part of the graph off and let's go on up here, because this is where all of our data is, and that we can put this spread out through this range right here. You'll notice, I think up here on this graph on our warm-up, yeah, look at this. They chopped off the bottom part of the x-axis. So they shifted the whole thing to the left here because they didn't have a 20-inch TV or a 10-inch TV or a 1-inch TV. So they said most of our TVs start at a 40-inch and they go in this range here. So we can do this kind of broken graph that we're using the space on the axis to its fullest. Okay? So sometimes I'm kind of surprised that kids haven't seen that before. It's like they tore part of the graph off. Here's after sunset, it's my title. So sun goes down, well that makes sense, the temperature is going down, real life experiences. And so hours after sunset, again they have a ripped graph here, and they said most of our data is up here, and so we call that a negative association. It's decreasing over time. And here we're talking about rainfall. I see my label here, hours after sunset, that's what it says down there, but this is like Arizona. We had rain, then nothing, cloud went by. Then a little bit later we had a downpour, still raining, then it went down, nothing, rain cloud passed by. So this guy's like all over the place. So there is no trend there, and so we say no association. You're good at this. All right, do these two real quick. We have no labels, so we don't know what all these numbers mean, but we can at least see what kind of association / correlation there is. So write those two answers real quick. Pretty easy ones. All right, hopefully you said positive association and no association. Sometimes, like on that coffee one, we talked about this in class today before the video. On the homework, that was the last problem. They said, you know, this is the coffee sales going across here. And so if you're in business and your data's like this, well, you know you're selling coffee somewhere in between these two guys. And so if we're going to make a prediction on how much coffee we need to order for next week, we can draw a trend line, a horizontal one that would look like this. I didn't say anything about that on yesterday's lesson because I just wanted to see what kids would say about this math problem. Because it says, well, how confident are you in your answer? But somewhere in this range here, I'm going to have coffee sales. So it looks like, you know, I get my regular customers. Sometimes they come in, and so I can start making some predictions that my coffee is going to be somewhere in between these two. I'm not going up in my sales, and I'm not going down. I'm just kind of hanging tight in there. Okay? So sometimes if they're going to force us in business or on graphs to draw a trend line, we can draw a horizontal trend line like this one. Okay? Just a little side note. All right, here we go with our trend line. And I am going to look at these two coordinates here, and we're going to write our equation for this, but I see my two coordinates on here are a little bit different. So we're going to be all right here. What we're going to do is we're going to write an equation for this guy. So they already sketched this guy, and as we look at this sketch here, because they gave us two coordinates right here, and they give us those coordinates of this, and sometimes they'll do that. They'll say, you know what, we drew a trend line here, and then we made these 2 points go through the trend line here, and so we're going to give you these. That way everybody has to put in the same equation, and there's only one equation for this. So anytime they do this, you have to use their coordinates in finding the information. So I want to be real careful because I used one less on one of these numbers. I couldn't read it on my small point. Here's why. Because they said 319 are 2 points on the trend line. So let's go with this guy. We got 319 and 328 are 2 points on the trend line, even though up there they said just a little bit different. Yep, same one. So they changed my numbers here. That's why I was having a hard time last period. Let's go with their numbers here. 119 and 328. Let's use these guys. Now there's not really enough room to do my slope over here, so we're just going to write our final answer here. So let's do this guy real quick. It's going to take me a little bit longer because I have to use my calculator here. And right, but you do too, so try to beat me done. I'm getting 41.8. Let me write that a little bit clearer. I want to write it clear over there anyhow. So my slope is a 41.8 for that guy. Yep, it's decimals now. You're older. Now, use the slope in one of the points to write the equation in slope-intercept form. Now, lots of kids like to use point-slope form. So we're going to pick one of these coordinates and use point-slope form. But we should, no matter what, come up with the same answer here. So, point-slope said y minus your y sub 1 equals my slope, 41.8, x minus my x sub 1, which in this case is a 3. I'm going to use this guy right here. Doesn't matter which coordinate you use, we should come up with the same answer. Alright, go to work. You should not be looking at my screen and writing whatever I'm writing. You should be doing this math. And I know that's a little bit harder to do when you're watching my video, but practicing doing all this work and practicing putting these numbers in your calculator and coming up with the same numbers as me, hopefully I'm doing it right. Every once in a while when I'm talking and working, it doesn't come out right. So there's my equation. So there it is, models the data. So here's my equation. Now I'm going to look, I got a negative 6.4 as my y-intercept. So if I go back up and look at that graph and that trend line, which are counting by, what, 50s here. So my trend line is going to be somewhere down here. So yep, that's reasonable. A lot of kids would say it's 0, 0, but it's just a smidgen off, and we're counting by 25s. That's a reasonable answer. So check that y-intercept as you kind of do your math work and finish your equation. So there we go. Now you can just kind of sit back and watch for a second here, because the way I was taught, and some kids do this, is they use the y equals mx plus b formula, and they say, hey, you know what, my y in there is a 119, and then my slope was a 41.8. My x in that coordinate is a 3, and I need my b. And so depending if you use point slope form or slope intercept form, we still need our y-intercept. So I'm going to show you we're going to come up with the same answer. We better come up with the same answer. I got 119, you can just watch this, equals 125.4 plus my b. And now I'm going to subtract 125.4 from both sides. And I got my b equals what's that for? Sometimes that's my ink. I got 6.4, so now I write it in form. My slope was a 41.8 x, and my b is a minus 6.4. So it doesn't matter which way you do it. Some kids like point slope. Either way, it's 2 steps. Okay, so it doesn't really matter as long as we get all of that down to the slope intercept form. All right. Says, what trend line in your slope intercept form models the data of the first graph? Try it. Oh, the previous example, number 1. Okay, so here's where we got to go. This was a little confusing. They do this now as we go through. And I don't know how you would do this if you were doing your computer like you're going to do next year for your notes. We need to go up here to example 1, and you need to draw a trend line down this little bad boy. So, pause your video, go back to that, draw a trend line for this guy, and now write your equation for that guy. Alright, while I'm here, I'm going to draw my trend line. Again, yours might be a little bit different than mine. Alright, go write an equation for your trend line there. Find 2 good dots. Here's one good point on my trend line. That one's a pretty 2 too. But I'm not going to force it. Let's see if I got another one here. This guy here is going to be like an 8, 6.9 maybe. Oh wait, that's, yeah, 6.9. So pause your video, come back here and write in it in slope-intercept form. This will take a little while, so pause your video and go to work. Alright, let's see how you did. On my guy, I had a 2-2 the first time that I drew my graph. I just redrew it this time, but on my paper I had a 2-2 and a 9-7. So let's see what a 9 would be right there. Yeah, my line was a little bit lower when I drew it on my paper here. So I had a 9-7. So either way, we should come close to an equation that looks very similar to this. Y equals 5/2 x plus 4/7. Now, yours will be a little bit different, but we should be kind of pretty close, okay? Explain why there's no data points on a trend line. Well, sometimes you just draw a trend line, and like mine, there was only one point that actually fell on my trend line, and then I had to estimate the other one. And so I had to make another point. And so it might not hit either one of those is what you should say here, but you're going to draw a line no matter what, right down the middle of your data. And then sometimes you have to come up with 2 points for your data and your slope on that guy from your trend line. Don't force it to something that's already there. I had one that just happened to go through 2-2. But up here, I had to make my own dot called 6.9. Okay, so don't worry about it if it's a decimal. You're in high school now, and we will get decimal ones. Okay, all right. Hopefully, you came up with something along those lines. All right, so here's a scatter plot, and we sketched it. They did, and here's one too where they came up with some points. Now the red ones is the data that they came up with, so the blue ones is 2 dots that they came up with on their graph, and that's why they wrote these 2 guys here. So you have to use these numbers that they said, you know what, we came up with this one and this one, so use these guys to write your equation. All right, and this is talking about internet speed, and so it looks like internet speed, if my speed is really slow, it takes a lot of minutes. Now look at, remember how Fisher said time's always on the x-axis? Most of the time, 99.9. Well, this now has time on the y-axis, which is kind of unusual. We're looking at internet speeds here, and we're looking at how long it's taken to download something. So every once in a while, time can be on that y-axis. All right, let's go see what we're supposed to do here. So we're supposed to use those 2 coordinates, which I need to copy down there, 3, 20, 10. So that's one of them. And my other coordinate that they want me to use is 585. All right, use the slope. They didn't use any of these guys up here. It says select 2 points on the trend line. So they give us the 2 points, go find the slope. Go. Let's round it to the hundredths place. I'm seeing a whole lot of digits. So let's round it to the hundredths place. That's most of the time now what we do. I see a 1, 9. The 9 pushes the 1 up to a 2. There's a 1 right there and then a 9. So we're going to round it up to a 2. Use the slope and one of the points to write an equation for the trend line. So use one of these guys. Again, I don't care if you use point slope form or slope intercept form. But we need to get our final equation here. Make sure you're putting in 0.02. I'm expecting a lot of kids to put 0.2, and I got a positive 6.4. I'm going to add 10, get that guy to the other side. And there it is in slope-intercept form. Now we can use that to make further out predictions. Now I'm going to go look at my y-intercept on that graph up there. 16.4. Yep, there's 14. So yep, my y-intercept's pretty dang close to 16. So that's a reasonable answer there. Okay. Now, they said use this equation in a linear model to find the value of x is 800. I want to know how fast or how long it's going to take to download 800. So we're going to put 800 in for the x. I think my slope up there was a negative 0.02 times 800. And then I need to look up there, plus 16.4. We're going to use that equation now to find more information. I have like a couple kids in my class that still don't have a calculator, and it's like, my goodness, you people, how are you going to do this? So I know negative 16.4 is going to leave me at what the y equals 0.4. So the download time would be, what, 0.4? What's our units up there? I think it's in seconds, maybe minutes. But it's in minutes, 0.4 minutes. Okay, so there we go, it's in minutes. And now, I think you have one to do. Now, what's the x-intercept of the trend line? They want to know what the x-intercept is. So again, we learned how to find the x-intercept. If we knew our equation up there was y equals negative 0.02x plus 16 point something, I think it was 16.4. Without my help, you should be able to say, okay, we want to know what the x-intercept is. So, how are you going to find the x-intercept? Let me give you a second to get started. I'm hoping that you put a 0 in for the y. I want to know in 0 on the y where my x is. So, let's go solve it. I'm getting x is 820. So my x-intercept is 820 megabytes, M capital B P S's per second. Okay, so that little line would be coming down here, and that's a pretty good estimate. It's going to be out here at 800 and something. Now they said, is that a possible real-world situation? But you have to think about, they just told us to say our minutes is 0 minutes. Is that really possible? In 0 minutes, I can download 820 megabytes? No, it takes a minimum of a decimal of a minute. So this is not reasonable, because transfers take some kind of a time, even if my x-intercept, well, you just can't be zero time. Nothing happens in zero time. By zero time, nothing's happening. So they want you to be a thinker. All right? You got to know that when I'm looking for my x-intercept, time is my y, so I want the y to be a zero. Zero time, I can't have anything being transferred with zero time. That's where I start at. Okay? So, kind of a higher level thinking question there. All right, and I think that might be it. Oops, you were supposed to do that one on your own, and I did a whole thing there. All right, so there it is. I cut some things out for tomorrow, but you must be able to write an equation here. So today we're doing the Savvas Online lesson. Okay, so tonight's homework is the Savvas Online questions. Okay, have a good day.